Hello, yet again, welcome to Haybridge Maths Department A level, where we're looking at Year 2 Pure and we're still working our way through Chapter 5, where we're looking at radians. You might notice a slightly different setup to the video this afternoon, or morning, or evening, or night, or whenever you're watching this video, because I've given up on trying to use a touchscreen and I've gone over to using a webcam. So hopefully my handwriting will be a little bit easier to for you to read. Now, we're going to carry on with working with radians to solve trig equations. Last time we did some very straightforward equations just to get you back in the swing of solving trig equations, but this time, of course, using our angle measure of radians. Got a couple more examples for you, and there are just two examples that I am going to do for you, and they are slightly more complicated. In the first example, we're going to use identities like we used in Year 12. They work the same as they do in degrees, as they work the same in radians. There is no difference. So in the first example, we're going to do that. And then in the second example, we're just going to do a problem where we've got sine 3 theta instead of just sine theta. Okay, so without further ado, let's go on and have a look at this question here. Straight out of a textbook, and in this problem we have 17 cos theta, and what would you know, I start off by using a different way of doing this, and the whiteboard pen runs out on me. How about this? 17 cos theta plus 3 sine squared theta equal to 13. This makes it seem like I've just done this on the hoof, and I haven't. I've been practicing this a bit already. As you can see, I put an X there to see if it would focus, and it's lost its focus. So what we're going to do is we're going to carry on writing, and hopefully it will begin to pick up what we've done. Maybe I should have stuck with the touch screen. How about that? So we've written the domain down as well. Still can't see that. Right. Now, let's just point at this sine squared here, which hopefully you can see, and you can also see that we've got the cos here. So I'm looking at the actual question here. What I'm going to try and do is get a quadratic. It's going to be a disguised quadratic, but the problem is we've got sine squared and we've got cos, so we need to change this so that it becomes all involving cos squared, or cos. And we've got an identity from Year 12. We know that sine squared plus cos squared equals 1. So in other words, sine squared is 1 minus cos squared. So we can rewrite this line that you can't properly see at the moment. We can rewrite this line as 17 cos theta plus 3 1 minus cos squared theta equal to 13. I can now expand out this bracket, so we get 17 cos theta plus 3 minus 3 cos squared theta equal to 13. We can now do some tidying up. You can see that we've got 13 here and 3 here. So what I'm going to do is I'm going to move everything here onto this side. Why am I doing it this way around? It's because I've got a negative 3 cos squared theta, and I'd rather have it as a positive. So I'm actually going to move this over to here, this over to here, and this over to here, so we get a lovely 0 on this side. But because I haven't got much room here, I'm going to also flip it round. So let me show you what I mean. I'm going to write this as 3 cos squared theta minus 17 cos theta plus 10 equal to 0. Now, if you're feeling really confident with trigonometry and algebra, you might want to skip this step. I wouldn't. If it was me, I would go let x equals cos theta and rewrite the equation as 3x squared minus 17x plus 10. As you get closer to your exam, you might just leave it in terms of cos squared and factorise directly. Here, though, we're going to leave it like this, and I'm going to factorise this now so that we get 3x minus 2x minus 5 equal to 0, so that we get x equals 2/3 or x equals 5. Now, if x equals 2/3, then that means that cos theta equals 2/3, and of course you can't have cos theta equal to 5, so there's no solutions here. Last one to go then is just this cos theta equals 2/3. If we think about the graph of cos between 0 and 2 pi, here we go. Oh, there we go. A lovely Big Dipper shape there. We've got 2 pi. We're looking at 2/3. Where is cos theta equal to 2/3? Well, it's going to be this value here, the principal value, and it's going to be this value over here, which will be whatever this is, but 2 pi minus to get that. So if you do inverse cos of 2/3, you get theta equals 0.841, and theta equals 2 pi minus 0.841, which I'm just about going to squeeze in, which is going to be 5.44. Hopefully you can read that. The camera's icons are kind of in the way there. If I just shift the board over slightly, can you see that? I think that's about as good as we're going to get. But there you go. So make sure that you pause. I'll just make sure this bit here is copied down so you can read. Pause, copy all this down, and then once you've got that into your notes, we'll have a go at the next example there, which is going to be this question here. Okay, so I'm going to rub all this out here. What I need is a second whiteboard. Okay, bear with me. It's not the most thrilling video, I imagine, watching somebody rub out a whiteboard, but there you go. Right, we're back. Okay, so we've got sine 3 theta equals root 3 over 2, where theta again runs between 2 pi and 0, or 0 to 2 pi. We're struggling to read that, but you can see it in the question on the left-hand side there of the screen. Okay, again, you might want to jump to, you might want to skip this step when you're really confident with trig. If you're not confident with trig, don't skip it. It's like riding a bike non-handed. Yeah, it looks cool until you fall off and like smack your face. So don't ride a bike non-handed. Don't skip this step out if you're not feeling really confident with algebra and trig. So write it as x equals 3 theta. But now we've got the fact that sine x equals root 3 over 2. Still not seeing that properly. Hopefully that will resolve itself quite quickly. And if you've got 3 theta, x is 3 lots of theta, and you've got theta here, which you can hopefully you can just about work out. Then we're going to times this and this by 3, as well, so that we get x is between 6 pi and 0. We're still not focusing on this, which is very frustrating. So let's have a look at the graph of sine between 0 and 6 pi. So here we have a very long graph, and it is going to be the sine graph repeated 3 times. 1, 2, 3. There you go, 6 pi. And even better, you can see what I was actually doing now. So we've got 6 pi there. We've got, of course, 2 pi here, 4 pi here. So if we're looking at root 3 over 2, then the principal value will be given this one here, but we're going to work out this one, this one, this one, this one, and this one. So we're looking at 6 values here. So if I do an inverse sine in radians of root 3 over 2, or you remember what it is, then you just know your exact values. Either way, you get x equals pi over 3. This value here will be pi, so it is going to be pi minus pi over 3, which is 2 pi over 3. And then we're just going to add on 2 pi each time, so we're going to get 7 pi over 3, 8 pi over 3, and then add on another 2 pi, so you get 13 pi over 3, and 14 pi over 3. But the question didn't say find x, it wants you to find theta. So if x equals 3 theta that we have at the top here, then of course theta equals x over 3. So we're having to divide each one of these values here by 3. So we get theta equals pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. And we're done. So, 2 slightly more tricky examples, probably because we're marrying stuff from year 12 that was quite hard then with stuff to do with year 13. By the time you can run to your exams at the end of year 13, this will be absolute bread and butter. We've got a long way to go with trig, and this is just one small part of it that you'll need to use over and over again. So I guess my message here is make sure you're really fluent at this. You can do this sort of thing with your eyes shut and one arm tied behind your back. It's that sort of level. We need you really kicking on all cylinders with this. So without going on about this anymore, could you make notes if you haven't done so already, and then have a go at the next exercise, which is exercise 5e. Thank you very much. Goodbye.